evaluate the limit as x goes to 0 of tangent 6x over sine 4x. To evaluate any limit, the first thing you should always do is take your limit value, plug it into the functions, see what happens. So in this particular case, tangent 6x would evaluate to, well, tangent of 0, and tangent of 0 is 0. Sine of 4x, that would be sine of 0, which is also 0. So this gives me the indeterminate form 0 over 0, which is a situation where I can use L'Hopital's rule in order to evaluate the limit. So I will apply L'Hopital's rule. And L'Hopital's rule says that this is equal to the value of the limit whenever if we take the derivative of the numerator. So the derivative of tangent is secant squared. And since this is secant squared of 6x, we leave the inside function alone first, and then we multiply by the derivative of the inside function. Then that's divided by the derivative of sine 4x. The outer function is sine, its derivative is cosine. And then we multiply by the derivative of cosine 4x, of course. Then we multiply by the derivative of the inside part, which is 4. Now, if we were to reevaluate this, let's see what happens. So plugging in 0, well, secant squared of 0. Let's take a moment to try and figure out what that is. So secant squared of 0. That's going to be the same thing as 1 over cosine squared of 0. And just so we know how this is evaluated, this means cosine of 0 quantity squared. That's what this shorthand notation here means. Cosine of 0 is 1. So this is 1 over 1 squared, which is just 1. So secant squared of 0 is 1. And then I have this multiplier of 6. Cosine of 0 is also 1 times 4. So this is going to result in 3 halves.